previous tree that you built, I think you can see that it used the Gini here. Can you see? I'll explain about what is Gini. Uh, Guys, look at this. The default parameter of the decision tree classifier, the one that you use is here. If you look at the parameter that you can provide from here, that is, can you see? Colab show you the hint that the criterion, the default one is Gini, and you can choose entropy also, the one that you more familiar, right? So you can use entropy here. You can type entropy and you can see that this is the values of entropy, that it should be the one that you familiar. The entropy here is the entropy of the sample in this node. Okay, so it is like it can find the gain of the attributes using comparison of entropy. Entropy of the first node here, right? That is 3 of negative and 1 positive, right? And the entropy is like this, 0.811. And if you divide it using x2 is less than 0.5, or if x2 is true, so the example will be two examples that fall into this leaf. So and all of them are false. So the class is false, and you can see that the entropy is 0, right? But here there are two examples that are 1 and 1. Both of them like one from positive and one from negative. So you cannot classify it yet. So you can see that here the entropy is still 1.0, that is greater than the entropy from the starting point here, right? Okay, so guys, now I'll explain about the Gini one. What is the Gini? For the entropy, of a set S, it is the summation of all class V of the probability of V and log of probability of V. Okay, log base 2 of PV. So this one, it is the values of entropy. You can see on the right side, this is the values and the function of entropy that we familiar, right? And how about the Gini impurity? For the Gini one, for the Gini of any set, it is the summation of all V's of the probability of class V times 1 minus probability of V. So this is the values of Gini. In this video clips, I'll show you the behavior of both values. So I'd like to start with, I'll use the matplotlib to show you the graph. So I will use numpy to create an array of x and y. And we use the matplotlib one to show the graph. So for the values of x, I will start with, because this is a probability, x will be the probability of class positive. So I will use np.arange, start from 0 to 1, and the step is 0.05. And the values of y of entropy will be, it is a summation of all class, right? And in this case, we have two classes. X is for positive, so I'll use the values of x first. Log base 2 of x plus, this is the the probability of the negative class, so it must be 1 minus 1 minus x, and np log 2 of 1 minus x also. But this one must be sum of minus, right? So you can see that it is sum of minus So this term must have a minus here. So I'd like to remove this one. Okay, so this one is the values of entropy. We can check it, and okay, I think it is oh, this one is sometimes is warning 0 because there is a log of x will be 0. So if I would like to slightly change, if you don't want to be like to be warned, because logs of 0 we cannot find it, right? So I will make it like start from 0001 instead. So the y of Gini will be two class same. So it must be x times 1 minus x, right? And plus x times 1 minus x. This is the probability of the negative class times 1 minus x. So this is why Gini and why entropy. So guys, I'll plot it x and y entropy, and plt dot plot x and y Gini. That's all. Okay, so now I think you can see that the they share the highest point at 0.5, right? Right. This part, this one is the highest point of both, but the values, this one increase a little bit sharper and faster and decrease faster. Okay. But for the Gini one, it will be like this. Okay, so this is the difference of the Gini and entropy. So it should be in the same, like the same ratio, but the absolute values of the highest one is different. Okay, so I hope that you can see we can use other function in the tree. So hope you enjoy that, and see you in the next video clip.